Welcome back to Through Inquisitive Kids. My name is Karen, and this is the last lesson to Chapter 9 of our 8th grade series. And today we will be applying solution sets of inequalities to different word problems. And today we will also be focusing on solving more complex inequality problems and word problems. This unit was all about inequalities, their properties, how to solve them, and inequality word problems. Now, in this lesson, we're kind of taking every single aspect of that and just taking it to the next level. So today, the word problems will definitely be more challenging and exciting as well. So let's dive right into it. The two learning goals of today is to solve complex unary linear inequalities and to explore the practical application of unary linear inequalities. Introduction. A triangle's sides is 3 centimeters and 7 centimeters. What conditions must the third side, x centimeters, meet in order to enclose the triangle? Now, in order to answer this question, make sure you're thinking about the properties between the sides of a triangle that we've went over before. And that property of a triangle is that if you take any side of a triangle and you add the two other sides, that sum has to be greater than your first side. And if you take the difference between the two other sides, then it has to be less than the side that you have. All right, so referring back to that property, we can answer this question. Using the relationship between the three sides of a triangle, we have two inequalities. X is greater than 7 minus 3, which is equal to 4, and x is less than 7 plus 3, which is equal to 10. All this means is x is greater than 4 and x is less than 10. So the value range of x would be greater than 4 and less than 10. Solving complex unary linear inequalities. Example 1. Solve the system of inequalities. Here we have x plus 5 is less than 3 and x plus 6 is less than 4x minus 3. Pause the video and use your knowledge of systems of inequalities from the last lesson in order to solve. So the first step is to always solve each individual inequality. After simplifying the first one, we have x is less than negative 2. After solving inequality number 2, we have x is greater than 3. And now we represent these two inequalities on the number line. So here we have x is less than negative 2 and x is greater than positive 3. But as you can see here, these two inequalities don't overlap in any part on the number line, which means that this inequality group has no solution. Solve this set of inequalities. Now we're on example 2. As you can see, this is much more complicated with parentheses and denominators. Again, take it easy and figure this out step by step. It is more complicated, but that doesn't mean the order of the steps has changed. All right, so again, we have to first simplify each individual inequality. After solving inequality 1, we have x is greater than negative 2. After solving inequality 2, we have x is greater than 6. By now, I'm pretty sure you've mastered removing denominators, combining like terms, and all of that. But when simplifying inequalities, remember that unlike solving linear equations, there is a property 3 of inequalities, and that is if you multiply or divide the same negative number onto both sides of the inequality sign must change. Anyways, after simplifying, we can represent these two inequalities on the number line. And we see that they do have a common part. And the common part shared by inequalities 1 and 2 is x is greater than 6. So the solution to this set of inequalities would be x is greater than 6. Example 3. Given that the solution of 2x minus a is less than 1 and x minus 2b is greater than 3 is x is greater than negative 1 and less than 1, then what is the value of a plus 1 times b minus 1? And I'll give you a hint on this one. Since you're already given the solution to this set of inequalities here with x as the variable, all you have to do is find the values of a and b and then substitute their values into this expression right here. All right, so this is a bit different from the other ones we've done, but we can write this right here. So by isolating x onto one side of the inequality, we know that x is less than a plus 1 over 2, and x is greater than 3 plus 2b. But since we also know the solution to this set of inequalities, and that is -1 is less than x, which is less than 1, we know that a plus 1 over 2 is equal to 1, and 3a plus 2b is equal to -1. Do you see how we substituted the value here, this solution? So after solving, we have a is equal to 1 and b is equal to -2. Therefore, the value of this expression would be -6. Applying systems of inequalities. Several cars are transporting a batch of goods, each with a loading capacity of 8 tons. If each car transports 4 tons, there will be 20 tons of goods left. If each car transports 8 tons, the last car will be neither full nor empty. How many cars are transporting this batch of goods? Now, this is a word problem involving a set of inequalities, and I'm going to go over this with you first. So the first step is to always set the variables. Let there be X cars and this amount tons of goods. Based off of the quantitative relationships from the problem, we can write these two inequalities. 4x plus 20, which is the number of tons, is less than 8x, and 4x plus 20 is greater than 8 times x minus 1. Solved, this inequality set would be x is greater than 5 and x is less than 7. So this solution set right here doesn't include 5 or 7. But since x can only be a whole number, then x has to be equal to 6. So there are 6 cars transporting this batch of goods. Remember, if you just answered this inequality right here, then you wouldn't have gotten this question right, because remember, this is a word problem, so you will need either a full sentence or a unit. Depends on what your teacher requires, but after solving, it's usually good to see if this fits to the question that is being asked. Class summary. Today we learned all about systems of inequalities. This led to solving complex inequalities, and its steps were removing parentheses and denominators, solving the inequality, and then finding the common part of the solution set of each inequality to find the solution set of the entire system of inequalities. Systems of inequalities also led us to its practical use and application, especially in word problems. Again, today we solved complex unary linear inequalities, and we were able to explore the practical application of unary linear inequalities. Thank you so much for watching through Inquisitive Kids. This lesson wraps up our unit on inequalities and its properties and all that. And the next time you will probably see me in one of the Through Inquisitive Kids videos would be in chapter 11. So in order for more videos from me or just Through Inquisitive Kids in general, please be sure to hit that subscribe button in order to get notified the next time we upload. Again, thank you so much, and we'll see you next time.